this last section on gas stoichiometry is pretty short. It's going to combine the gas laws we have learned with stoichiometry. So, all the conversions are typically going to be using the ideal gas law and some kind of information from a balanced equation. And you're generally going to convert between these four things, either the pressure, volume, and temperature of some gas into one of these, or the pressure, volume, or temperature of another gas into one of these, or maybe somewhere in the middle. And that's really all there is to this. So here's a sample problem. It says, in the balanced equation above, what volume of hydrogen gas at 765 torr and 225 degrees Celsius is needed to react with 35.5 grams of copper to oxide, CuO. So we're going to start this one with the stoichiometry side of things. We know we're going to react this much copper to oxide, 35.5 grams of it. So the first step is to divide by the molar mass here, which is 79.55. And then we have to turn it into moles of H2. So we multiply times the stoichiometric ratio, right, which you should remember doing. 1 mole of H2 over 1 mole of CuO. And we end up with moles of hydrogen gas, which is 0.446 moles. The question wants to know what volume of hydrogen gas is that. So we're going to take that information, 0.446 moles, and combine that with what we know about the pressure, 765 torr and 225 degrees Celsius, and plug that into Puvnert's and solve for V. V is equal to nRT over P, and plug in N, 0.446 moles, R, 0.0821, T here we have to add 273 to 225, so that's 498 Kelvin. And the pressure, 765 torr, is 1.01 atmospheres divided 765 by 760. And with three significant figures, we get 18.1 liters of hydrogen. So you would need 18 liters worth of hydrogen gas to react with just 35.5 grams of copper to oxide. So really that's all there is to these problems. Just if it's a matter of starting with stoichiometry and using the gas laws, do that. Sometimes it's starting with the gas laws and then working through stoichiometry, which is what the next problem will be. Okay, so this one says, what mass of potassium chloride forms when 5.25 liters of chlorine gas at 0.950 atmospheres and 293 Kelvin reacts with 17 grams of potassium? First thing we need is a balanced equation. So that's what we've got here. Okay, so the only difference in this problem is that it gives us information about both of the reactants, 17 grams of potassium, and it gives us some information about the chlorine gas, which we can solve for moles. So we know both of the amounts of reactants, which means this is really a limiting reactant problem. So I first got ahead and solved for the chlorine. Let's figure out how many moles we have of that. So plug the information into Puvnert, solve for N. 0.950 atmospheres is the pressure times a volume of 5.25 divided by R times 293 Kelvin. We get 0.207 moles of chlorine. Then it's just a matter of stoichiometry, figuring out which one produces the least amount of product. So the 0.207 moles of chlorine times the 2 moles of KCl for every 1 mole of Cl2, and then multiply times the molar mass of KCl, right, that's just stoichiometry, gives us 30.9 grams of KCl. And then the other one, the other reactant, 17 grams of potassium, first divide by the molar mass of potassium, 39.10, times the stoichiometric ratio, in this case it's 2 over 2, and then it's multiplying times the same molar mass as the first one, and we get 32.4 grams of KCl. These are both pretty close, but this one makes less, which means that this is the answer here. That's the most we can make. We don't have enough to make this one. So 30.9 grams of KCl is the answer, and Cl2 is the limiting reactant if it were to ask you about that. So really that's all there is to this. It's just a combination of using the gas laws, usually Puvnert, combined with what you know about stoichiometry.